Welcome to the class. In today's class, we will look at Introduction to Artificial Neural Networks. Artificial neural network is an information processing system. What is the meaning of information processing system? If we say like this, the system will take an input, it will perform some operation on that input, and then it is going to produce the output. That is, ANN is an information processing system actually. And this is inspired by the functioning of the biological nervous systems. That is how we have the brains in our human body actually. This ANN attempts to imitate the fundamental working principles of the brain rather than the complete complexity. In the sense, we'll not try to model the entire brain. We will just look at how the fundamental working principle that can be modeled using the ANN actually. ANN consists of many interconnected processing elements. Correct? That is, one processing element is called as a neuron, and ANN will consist of more than one processing element or more than one neuron actually, that operates together to solve specific tasks. That is, some set of neurons will be there which will be working together to solve one specific task. That specific task can be like spam classification, face recognition, and any other pattern recognition problems. In the sense, if we have designed an ANN1 for face recognition, then we should design another ANN that is say 2 for the spam classification. In the sense, it is one network is suitable to solve one specific problem. And how we the human beings will learn by looking at the examples for the to make the ANN to solve any specific task. Actually, we have to provide the input examples through the form of the training process. In ANN, neurons are interconnected through connections. Actually, that is, they will be interconnected through interconnections. Each connection has been associated with the weight. That is, one connection, every connection will be associated with the weight. Weight is nothing but a number actually. This number can be a positive, negative, or it can be integer or a or a decimal number, anything like that. The network uses the weighted connection to process the information and solve specific problems. That is, weighted input is required actually to process that particular information and solve the specific problem. The overall behavior of the ANN is reflected in its ability to learn from the data, remember pattern, and generalize to the new inputs. That is, ANN should have the ability to learn from the data. That is the first thing. And it should also remember that patterns, and also it should generalize for the any new, that is the test data which has been there. If it does this thing, then it is going to able to solve the problem, or else it will not be able to solve that particular problem. Artificial neural networks are designed to imitate in a simplified way the network of neurons found in the biological brains. The basic processing element of the ANN is called as neuron or artificial neuron. This is, neurons is something like which we have in our brain, but here as a part of this particular course, in the sense when we take, we are trying to imitate that one. Therefore, we are going to call this as an artificial neuron actually. Now, today's class, we will look at what is a model of the neuron means and what is a maths behind that particular neuron actually, like how it processes the input and produces the output. A neuron is an information processing unit, and like when we say this one, you always remember it is input, it should take input, it should produce output, but it should do some operation by performing that operation on the input, which is, this neuron is an information processing unit that is fundamental to the operation of the neural network. In the neural network architecture, the neuron model is going to look like this. You should remember this diagram. You will learn over that as we keep going in the course actually. It is going to take the input actually because it should process the input. The input signals are represented as x1, x2, xm. Usually this xm, x input, that is we call this as xj, will be in a number actually. It can be a positive number or a negative number, or it can be integer or a decimal number. As I said earlier, this input is being weighted by some input weight actually. And this weight is also in a number actually. Some number actually. We will learn over the period like how we will initialize this weights, how we updates. But you assume that now this is each input will be associated. Here weights you can see it is WK1 and WK2 and WK. That is here WK and then J. And here my input is XJ. Therefore, now first input when we take, it will be X1 and its weight will be WK1 at. And now it has one operation here, that is summing operation. This input signal will be multiplied with the weight, and then next once again another input signal and multiplied by this particular this thing. It keeps going on up to xm and then wkm. That's the thing. That is, this expression is going to form for the that is a summing operation which we are going to tell here actually. And sometimes we refer this one as this model as a model of the neuron K, because WK in the sense waits for the neuron K actually. Now, after doing the summing operation of the input with the weight, it will be added with the bias input. Later in the upcoming classes of this course, we will learn what is the importance of this bias. But you understand now one bias will be added for this one, and that is BK. Once again, this can be in a number which can be positive or negative, anything. Now, this summing expression value we will get in VK actually. That is this summing expression plus bias is going to form the VK. And that VK is going to go as an input to this particular function, the activation function. That is some function F, and that will be given as an input. And this will produce the output, that is the YK. In the next slides, I'll show what is this activation function and why it is required and what it is going to do. But basically, you understand this one. It takes the input, summed by multiplied by the weights, and then summing of that particular this thing, and then adding to the bias, and then passing through on a function and getting the output. Now, the basic three components of the neurons are the connections, what we have seen here, that is x1 multiplied by the weight actually. This connection, sometimes we'll call it as synopsis or connecting links actually, each of which is characterized by the weight. Every synopsis will be having the weight actually. Learning. Training or learning rules adopted for updating and adjusting the connection weights. That is, when we take WKJ, it will be having some value. But later when we have to learn something, how we have to update. This updation is nothing but the learning actually. How we are going to update actually. And then in the learning process actually, an adder for summing the input signal weighted by the respective synaptic strengths of the neuron that is being done. And the other one is a activation function. Sometimes we call this as a squashing function. Activation function for limiting the amplitude of the output of the neuron. See, this expression when we take VK actually, this can be a large positive number or a large decimal number or vice versa, negative also. But when the input is large and then we want to squeeze it to a range, say 0 to 1 or -1 to 1 actually. At that time, we need this particular activation function because it is a mathematical expression. This VK can be anything. It can be a too small value or it can be a too large value, anything actually. But when we want to squeeze the output in the range of 0 to 1 or minus 1 to 1 or anything actually. Like we want to squeeze the output in some range actually, then we go with this particular activation functions actually that is required. Now here, what is you're looking at is a simple example of a neuron with two inputs. At that time here, the y expression will be x1 multiplied by w1 and then x2 multiplied by w2. Say if I add one bias b here, then b will be added here. Now, if I get this particular y in as an output of summing this one, then inside this, before we pass it to y, we have to apply this to an activation function y in and then get that particular this thing, and this output we are going to get as this particular this thing. That is, this is the activation function, and this y in will be this one. That is y in. If I add bias, it adds the bias and then we get it, or else we will not get this particular this thing. Now, that is, yeah, this is an example of the input neuron with x1 and x2 are connected to the output neuron y over the weighted interconnections. The weighted interconnections are w1 and w2. And in this one, y in will be the x1 multiplied by w1 and x2 multiplied by w2. And if we consider the bias, then the bias will be added. And here, the f is nothing but the activation function, which will be passed actually. This is what the simple example demonstration of the model of the neuron actually. As I said, the mathematical this thing, the WKJ, that is WK in the sense K is the neuron, J is the input actually of that particular this thing. If I have one more neuron, then its weight will be say WK, that is if I take my neuron as P, then it will be WPJ actually, and then it will be this thing. That is, this model of neuron forms the basis for designing the artificial neural networks. That is, you should be comfortable with this particular model. Now, we will look at the mathematical terms of the neuron K actually. That is here, this UK actually. That is this, when we expand, what we are going to get? WK1 and X1, then WK2 and then X2, and it keeps going on up to WKM and then XM, because here M inputs are there actually. And now we have a bias here actually. Therefore, this UK will be added with the bias term, that is BK actually. And that we are passing with the activation function. That is, activation function is denoted by the pi symbol here actually. And this UK plus BK can also be represented with VK actually. That is, this is what here actually. That is, this VK is nothing but the multiplication of this input with the weighted input, addition of the bias, and that passing with the pi function, and then the output actually. That is, sometimes this model of the neuron is also called as a nonlinear model. The nonlinear model is because up to, if you see here, VK, it is a linear because you are having expression and this is getting added with the BK. You are going to get something actually. Well, that is, it is some out for the input, some output you are going to get for sure. But now when I apply this to an activation function, it becomes nonlinear. Like, why nonlinear? In the sense, we will be squeezing the output in some range, that is 0 to 1 or minus 1 to 1